Hey, Topping Life's Math and History, and we're gonna take a look at the different types of functions. So, in the past videos, we have been taking a look at functions. We have also been taking a look at the vertical line tests and graphing them on a graph. But we gotta find out what this kind of function this is. So, the three types of functions are a polynomial function, a radical function, and a rational function. So, what do you think this function is? This type of function is called a polynomial function because polynomials are really good at inserting anything for x because your f is going to be your output, while your x is going to be your input. Anything that you insert in for x will give you your output. So let's insert 3 in for x. 3 times 3 is 9 plus 7. That's going to be 16. Your answer of f is going to be 16. Polynomials are great when you want to be creative, and these kind of functions are actually allow you to have any number inputted into x. When you first learn about what a function is, your math teacher might first show you a polynomial function because it's the easiest way to understand functions, and your math teacher can easily teach it to you, so it's very simple. So, these are the first kind of functions that you will see when you learn the unit. So, the main specialty is you can insert anything in for x. That is why we say the rule is when we find the domain, that's going to represent our input. The domain is going to have colons. Then we're going to have lines right here, and we're going to say x can be an element of all real numbers. The word, or the letter E, means the word element. That tells us that x can be inserted into this equation for any real number. Any real number can mean pretty much anything. So x is going to be an element of all real numbers. Or if you want it as an equality, negative infinity is going to be less than or equal to x, and x could be less than or equal to infinity. There's actually a really fun fact that you might think infinity is actually a number. Well, infinity is not a number, it's actually a concept because there are infinite amount of numbers between 0 and 1, and there are many tiny numbers in between them, which are tiny, cute decimals. And if you really like big numbers, then people and mathematicians use infinity to count upwards, and it tells you that there's no biggest number. It just keeps going and going and going and going and going. You will learn more about infinity in your years of calculus. So let's move on to the next function. So here's our next function. The function of x is going to be the square root of x? Huh? So what kind of function is it? Yes, it's called a radical function because there's a square root symbol included. When you find the square root of something, any numbers or number inside of it is called the radicand. And that's saying that anything that you insert in for x will be the square root of that x. Like the f, what if x was going to be 3? Actually 9. What if the x was 9? The square root of 9 is going to equal 3. So that tells you that 9 is the radicand. So that can tell us that this is going to work. But what happens if our x is going to be a negative 9? The thing is, you can't really find negative 9. You can't really find the square root of that. And when that shows up, that is going to be called a complex number. So, you will learn about complex numbers in higher level math, but right now, you can't really square root a negative number. So that's why when we find the domain, our rules are pretty much almost going to be the same thing. X is going to be an element of all real numbers, except we have to add in another rule in here. Whatever we insert in for x has to be at least 0 or more, because if you find the square root of 0, then yes, it's still okay. But if you go into negative 1, that's sort of upping it a bit. And number 2, that is, negative numbers are not 0 or more. Whatever you insert for x must be at least 0 or more, because you can't find negative square roots. So this is our rule right here. Here's an example where this rule would play in real life. So, what happens if you come across this on your test? What we gotta find out is this right here, the radicand inside the square root, has to be greater than 0, or greater or equal to 0. So what you want to do is simplify. Add this by 3, add this by 3, so we get 2x is going to be greater or equal to 3. Divide the two sides to get x alone, and x is going to be greater or equal to 3 over 2. So that tells us that this is going to be a true statement, because there's no negative number inside the radicand. Let's move on to our final function. So f of x, or the function of x, is going to be 1 divided by x, or as a fraction, 1 over x. What kind of function is it? Yes, it's called a rational function. Rational functions are always going to have x as a denominator, as a fraction. So let's insert something in for x. Let's say 4. So we have 1 over 4 in our fraction. And that's pretty much our answer to this function right here. If we have a fraction as a function, that is actually still acceptable. But you're going to get something that looks like this. 1 divided by 1 over 3rd. That is called a complex fraction. And you don't really see this in algebra. So this can be the same thing as saying 1 divided by 1 over 3. When we solve this, we multiply by the reciprocal. So switching this 3 to the top and this 1 to the bottom. So 1 multiplied by 3 over 1, 1 times 3 is 3, and 1 times 1 is 1. So 3 is our answer when we have this right here. But what happens if we try putting in for our function a negative number? It's still pretty much gonna work. So 1 over negative 2 is going to be the same thing as negative 1 over 2. And there's our answer. There's actually one function that will never, ever, ever work. And it's the function of 0. When you try and add 0 as a denominator on a fraction, it's not going to work. Because when you do that, your answer is going to be undefined. You can't divide by 0. And when you do that on a calculator, let's say 8 divided by 0, you're going to get an answer as error. Your calculator will say error because you can't divide by 0. So we're going to make a rule that says the domain, or whatever you put in for x, can be x is going to be an element of all real numbers. But there's one more thing, that x can never ever equal to 0. When you have equal signs and a strike through, that means not equal. So x can never equal to 0. Here's an example where you would want to avoid this in a rational function. So we have the function of x, and we have this fraction right here. If x, or the denominator, equals 0, then that's going to completely bust the whole fraction, and your answer is going to become undefined. There is a way to test this so you know what not to put in for x. We're going to say 2x minus 3 can never equal 0, because that is what causes it to be undefined, if a 0 is on the denominator. So, if we add this side by 3 and add this side by 3, just like we did in the radical functions, we get 2x can never equal 3. And when we get x alone, we're going to get x can never be equal to 3 over 2. So that tells you what number not to insert in for x. That tells you if you insert 3 over 2 in for x, then your denominator will become a 0, and your answer will blow up and become undefined. So doing this method will prevent you from putting in a number that will drive you to 0. So, if you try and have a slope on a graph that is 0, then that is telling you that the slope is not actually a slope. It'll go straight down to the ground, and you will be falling. 0 does not make a slope either on a graph. We have now learned the 3 different types of functions. Thank you for watching Taoping Airlines Math Industry. Like and subscribe, and I hope this video has helped you.